going to show you in this toolbox that I have open the 5 major functional categories of operations that the toolbox can do. So the 5 main functions are in these blocks and they're color coded. The admin functions, these are things like the information about your sites, information about your samplers, information about the people that you have on your team, and it may be just you. The toolbox has to start off by knowing these items so that then when you import data, it knows when you tell it site 2, instrument 3, what instrument and site to associate that data with. Most of these operations you just do one time, and you only have to go back into this if something changes, like you move a sampler or you add a site or a sampler. Looking at these admin functions, if you click this one, the add or modify personnel, site, and sampler information, you can see that there are 6 buttons here. Let me just show you first. Click here for help file. And that opens up the standard operating procedure for administrative tasks. And what's cool about these SOPs also is that they are hyperlinked even within them. So if you're wondering about one particular button, for example, View Site and Sampler Inventory Report, which shows up here as the bottom button in Admin, you can look at the SOP that opens up and then just hover your cursor over one of these items in this table of contents, control click, and that jumps you to the point in the SOP that talks about that site and sampler report. So when you click one of these buttons, for example, modify existing sampler information, it leads you to another form that lists the samplers that you've already entered in this admin portion of the toolbox and asks you which one of these you would like to modify. You can see there's an exit form button here which closes this form, and that takes us back to the main switchboard. So the second of these 5 blocks is the data inflow. This is the area where the toolbox has functions that pull data into the toolbox. And you've got 2 options, continuous and met monitoring, which just means data that is produced from an analyzer in the field that you don't have to mess with a report from a laboratory for, and then filter method monitoring. And filter method monitoring basically works the same way, where data comes into the toolbox. However, with filter methods, you have data from your analyzer or about your analyzer and how it ran during that 24-hour run. And then you've also got data, the very important weight of what was on the filter from the laboratory. So you've got 2 sources of a data stream coming in. If you click on this top button, it opens up a form that only has 2 buttons. The top button is Enter Quality Control Data. We recommend that you enter QC data in 2-week intervals, for example. Most criteria pollutants recommend that at least every 2 weeks you go to the site and do some sort of a QC check. And we know that valid data is a data set that's bracketed at the beginning and at the end by passing QC checks. So if you click on the first button, this opens up the second scariest object in the toolbox, the QC data form. Keep in mind this is a one-size-fits-all form. Most of the time you will not have to enter data in all of these fields. And remember, the toolbox knows what instruments and sites you have, so it gives you selections in the drop-down box that are for your data. This is a toolbox that we've been working with because you can see there are already records here. And if I click the back navigation button, don't worry, we'll show you how to do all of this, but just to give you an idea, so you can see that there were 3 of these rows filled in. You can see that there was a flow rate check done and a temperature check done where you compare the temperature read by your field analyzer as compared to an external thermometer that you have for that purpose, or for example a delta cal or a tri-cal. A pressure check where you read the pressure read by your analyzer compared to the pressure read by your external handheld manometer. The toolbox calculates the differences. It gives you values in percent, and it attaches qualifiers or flags. If your values are greater than a certain percent off of what the known should be according to EPA's recommendations for measurements made to compare against the National Ambient Air Quality Standards as represented in the Red Book or QA Handbook Volume 2 data validation templates. What we've done in the Toolbox is take those data validation templates from the QA handbook, made them into flags in the Toolbox so that when your QC checks are greater than a certain % difference from what they should be, the Toolbox automatically assigns just a flag here. It doesn't invalidate this, but it's letting you know, hey, this value is more than 7%, for example. If you want to research where these flags come from, there is a hyperlink in the help file and also in the notes for this folder. Also, a super cool option of this form is to produce linear regression charts where you look at the slope and intercept.
And we will talk about that more in a separate video, all about slope, y-intercept, x, y, horizontal and vertical axes.
The next button, Import Raw Data File from the Sampler, begins the process of pulling data into the Toolbox. And it does conduct an initial review because obviously you're going to be looking at this data and there may be error codes or strange, very, very negative values. The way the Toolbox works is it works your data through a series of tables, 3 tables that form a pipeline for your data. In the first table, basically that's just anything you tell the Toolbox you want to pull into it. Your data come into a temporary data import table that looks basically just like your raw data. But then you have to tell the Toolbox what it is, what pollutant, what analyzer it's coming from, and that happens in the data verification table, what units these are, and then transfer the data to the archive table where it sits until you're ready to do the final data review and invalidation. And the data verification table stays empty once you move that data into the archive table. The next category of operations after you've pulled your data into the Toolbox is data review and validation. The second phase, for example, let's say you had an auditor come and they did some QC checks, they sent you the report, and you realize you need to invalidate those 3 hours when your auditor was doing checks, and the values produced by your analyzer represent whatever QC checks he was doing, not the actual ambient air pollution values. So that would be the second phase where you're looking at something in your logbook later after you did the import that you want to assign flags because you remember that a bird built a nest in the Met Tower and you hadn't invalidated the hour that it took you to fix that. So that's the second phase of data review. Then the final phase of data review is final data validation.
And final data validation in version 3.1 includes the use of a graph so that you can see your valid and flag data in context with one another. And if we want to assign AQS invalidation codes, you can see right here that we're looking at PM10 data, and whenever we use this function in the Toolbox, once you enter the information here, which again is all in drop-down boxes depending upon what sites and samplers you've set up and what your data are, you see the data here in context, and you could see that the data that were flagged when you did the import because they were out of range, or because, for example, in this case, there was too much change from 1 hour to the next to not be suspicious about that high value. Then you could go in and assign AQS null value codes here, or you can actually view the data and assign AQS null value codes in your data table itself. And what's really cool is that you can clearly see this outlier here in the chart. So let's take a look at the data, and you can see that all of the rows that have been flagged when you imported the data are in yellow, helping you more easily identify them. And this is clearly not valid data because we go from 8 at night to 9 at night, and we see a jump from 40 to 160 and then down again. So clearly this is an anomaly and we are going to invalidate this. We probably should do some investigation, but to show you how this works, we invalidated that, and now you could see that value no longer spikes up and the remaining values look reasonable. We still have to look at these two values here, but this is just an overview of how you can interactively look at your data, invalidate it in the context of the other data points for whatever time period you want. You could zoom in on a small time period, you could zoom out to a larger time period.
Then the next category of toolbox functions are the reports and charts. So the reports and charts are accessible from the main switchboard or from the fast track.
This is the reports and charts screen for continuous methods. So that includes any of your gaseous pollutants as well as continuous PM. And there are a lot of options, but it all hinges on this box here where you select the site, the sampler, the pollutant, and the sampling year. And again, if you've only got one instrument, that's what's going to appear here. So once you've got these selected in the drop-down boxes, and we're looking at PM10, it automatically populates this date range with whatever data are available for that year. But what's super cool is this question here, view data in spreadsheet format. So let's take a look at how we can use that. We've got PM10 continuous, and we want to look at a chart of the hourly concentration in this time period. And you can see this looks okay, it's definitely legible. But what about if we wanted to export that data and put it into another Excel chart? Perhaps we got data from an airport and we wanted to put those together and lay the two graphs one on one over each other. Then for whatever you select here, you say yes, view data in spreadsheet format. And then it gives you the data, showing blanks for when there are no records or that record is invalidated. And you can then just copy and paste that into Excel. Other reports and charts you can generate are quality control reports and charts.
So for example, a QC report gives you the results of any of the QC checks you've done. It can put them together so that you have a set of these one-page reports summarizing what happened during this QC check. Another example, so say you were monitoring MET data, including relative humidity, and monitoring ozone. The toolbox allows you to specify a starting date and time and an ending date and time and plot your pollutant against a MET parameter. Then the final category of toolbox operations is the AQS functions. That's right here from the main switchboard, and this bolded AQS data file creation is available from the fast track options as well. For AQS, first of all, you have to add the information of what AQS calls the protocol codes. And these codes are the pollutant that you're monitoring for, the method that you're using, the units that your data are producing, the time interval over which you make measurements, once an hour, once every 24 hours. And these codes form what AQS calls the protocol codes, and when you upload data into AQS, AQS has to recognize what these codes are in order for it to accept the data. The steps of entering monitor protocol data are, first, you only have to do it once, unless you change methods, you change samplers, and this can be accessed from the main switchboard or from whichever fast track you're in, AQS data file creation. One of the best things about the toolbox is it gives you these codes in drop-down lists. The toolbox has the up-to-date codes from AQS for the parameters, the method, the reported units, and the time intervals. Once you specify what data you want in your AQS report, then you tell it the time periods that you want. You tell it if you want your AQS ready file generated in pipe delimited format or XML format. The next step would be to inspect the data. So for example, for the raw data, that's what AQS calls hourly parameter data, whether it's pollutant or MET data. They call that raw data as opposed to the QA data. You click Inspect Data, and that produces an awesome report that generates summary statistics about the data just so that you can see if you've got outliers. It shows you if you've got values that are outside 3 sample standard deviations of the average for that particular data set. It also tells you if values are less than what EPA considers to be the absolute minimum for that particular method. It's a great report that then you can use, if everything looks good, to print it out and save it. It also has the option of adding AQS flags. These are not invalidation codes, but EPA has added this option in AQS so that you can give information about the data. For example, if you think that it should be classified as an exceptional event, you could add a flag here. Then you've looked at the data, you've determined everything looks good. Then you just click Create AQS Raw Data File.
The toolbox asks where you want to save the file.
And then you click View AQS Data File, and it produces a beautiful looking output. This is pipe delimited. We've got one row here where we've got an invalidation code, or because we had a machine malfunction. The homework for this module is to make a list of your sites and your samplers that includes what pollutants you monitor, or the MET parameters that you monitor for, the site IDs and sampler IDs that you plan to use in the toolbox, AQS site IDs if you have them. Please let us know if there are any error messages and we can work with you on that. Thank you very much, and that was Module 2.